Hello everyone, welcome back to another video of this section on my channel entitled How to Start With. On this occasion, I'm going to cover an instrument from a Chinese firm, which I really think that nowadays it's represent the greatest value for money when it comes to instrumentation. The firm is Rigol, and the device that I'm going to cover is the Digital Multimeter 3058E. Let's start it. As usual in my videos, you can navigate through them. Further than this introduction, section 1, in section 2 I'm going to cover the most relevant technical features of this digital multimeter built by Rigol, with a special interest in the port that I'm going to use in order to communicate with LabVIEW, and also I'm going to focus on the maximum resolution that you can acquire with this device when it comes to voltage measurements. In section 3, I'm going to deal with all the software that you need to install in your computer in order to make the digital multimeter work. Also, I'm going to focus on the minimum setup that you need to implement in Measurement and Automation Explorer. Finally, in section 4, I'm going to implement an application in LabVIEW able to measure the voltage from a temperature sensor, which is LM35, and in that way I'm going to measure the temperature. Without further ado, let's start it. Right, here we have our instrument, and the first thing that I'm going to pay attention is to the ports. The most visible one is this one that you have in the front panel, but as far as I know, that one is to store data. At least for communication is not suitable. If you want to find some port that is suitable for communication, you have to go to the rear part. And I'm going to put it like that to show you, okay? So here we have the serial port and also the USB port. That is the one that I'm going to use. To connect to the computer, I'm going to use this cable, typical one, so USB type B, okay, male, and the type A, also male. Typical cable that you can use or you can find for your printer, okay. And now it's time to focus on the resolution when you measure voltage. Right, voltage. If you want to measure voltage with a digital multimeter, first you need to connect your cables as I have here, positive here, negative there. Then the next thing is the ranges. So the digital multimeter has up to 5 ranges in order to get the better resolution. The minimum one is 200 millivolts and the maximum is 1000 volts, which represents a really high value. Alright, so watch out because 1000 volts is only DC. If we talk about AC, the maximum one is 750 volts. Measurements taken in this range of voltages are going to be recorded with different sampling rates, which can be modified. From a minimum one that is 2.5 till a maximum one that is 123 samples per second. Still, this value, 123 samples per second, is a really low feature, okay? So that means that this device is not suitable to record any experiment that is going to last a short time. For example, the discharge of or charge of transient of a capacitor, maybe that is going to last, I don't know, 100 milliseconds. For that kind of experiment, this is not your multimeter, okay? For that, better to trust in a big brother, which is the DMM3058, which has a better sampling rate. We arrive now to a thorny matter, which is the resolution. If you go to the datasheet, you are going to find that the resolution of the device is 5.5 digit of resolution. I say that it's a thorny matter because this is a very weird way to express what is the resolution, especially if you come from the world of analog to digital converter. When you have this equation where the input voltage full scale range divided into 2 power n, where n is the number of bits, is going to give you the resolution. So in what way can I establish some kind of analogy between the 5.5 digital resolution with the equation of Q that I have here. Okay, this is an explanation that I think that this device deserves. Imagine that this is the display of our digital multimeter, and we have 6 digits, and the first 5 digits, the less significant ones, are going to correspond to the 5 that we have here in the datasheet related to the resolution of this device. The 6th digit is the one which is more complicated to understand, because the one that you have in the numerator represents the maximum value of this digit, and the 2 represent the possible option that this digit can take. So it means that it is 2 because this value can take 1, which is the maximum, or 0, that is the minimum. So the less significant bits can go from 0 to 9. There is no restriction. The only one that you have restriction is the most significant one, that is the 6th digit. So in total, the maximum value that you can take here is 1999999. Of course, that one, okay, also you have to add an extra one, which is all of them 0. So in total, you are going to have 200,000 possible values. That values in terms of these devices or multimeter is also named as a number of counts. This number of counts is the little part that you can divide the section or the range in which you are working. In other words, so 200,000 counts are going to correspond to the 2 power m. If you try to solve and to get here the n, is going to give you a value of around 14 bits. With this information, we can find out what is the resolution which is attached to each range in which you can measure. So here you have, okay, some computation. For example, for the range of 200 millivolts, it's going to be 0.2 divided into this 200,000 counts, and that is going to be a resolution of 1 microvolt. For the highest value, which is 1000 volt, so the resolution is going to be 5 millivolt. Section 3 of this video related to the software that you have to install in your computer. I have divided this section in 3 parts. The first one, I'm going to cover the driver that you have to install in your computer in order to establish a communication between LabVIEW and the multimeter via USB port. The second part, I'm going to explain the minimum setup that you have to develop in Measurement and Automation Explorer to carry out, to establish that communication. Finally, I'm going to open the LabVIEW, and from there, I'm going to install a library or toolkit, which is going to help me implement the application that I want to develop. First, we have to install the driver, which is going to give us support for the communication through the USB port. That driver is NI Visa. To install it, we are going to open the NI Package Management. Here it is, the NI Package Management, and now I'm going to search for NI Visa. Here we have NI Visa is a very generic driver, which is going to give us support not only a USB port, but also parallel or serial port. In my case, I have already installed it. That is the reason I have here removed. In your case, if you didn't install before, okay, so you are going to have here install. Please click install and then take all the options by default that are going to appear, next, next, next. And you are going to install the Visa driver. After installing the NI Visa, is the moment to connect the device through the USB port to your computer and check that you have this device visible in Measurement and Automation Explorer. So here it is, the Measurement and Automation Explorer, and the thing that I'm going to do is to roll down devices and interfaces, and voila, here it is, okay? So we have there Rigol multimeter. Remember that also you have to check that in Visa option that in Passport, that one, okay, is not marked. Remember that this is needed for adapters to GPAB port to USB port, okay, and better not to have it, otherwise you can have problem with the communication. Next thing that I'm going to do is to establish a low-level communication to see that we can send commands, SCAPI commands, okay, and receive some kind of answer. So I'm going to open the Visa test panel and now input output, and this is a very well-known, okay, this very well-known command of SCAPI command that is going to ask the device, all right, who are you? What is the model? What is your brand? And the firmware that you have inside. So write, and here also I have to read. Here it is, Rigol Technologies and the model, okay, and then this is the firmware and the date of the firmware. Okay, everything done. So now we are able to send the SCAPI command, but also we can do it that easier with some kind of palit or VIs that libraries to make this communication easier. And that is the thing that I'm going to do next. Here we are in LabVIEW. As usual, I have created a new project with a VI inside that I call it, I named it as index. Now the thing that I'm going to do is to go to tools and now instrumentation and find instrument drivers, okay? I have to say that you have to log first in order to download from here, from this browser, the driver that we need. The thing that I'm going to do now is you have here the option of connected instrument. I'm going to roll down, and the thing it's going to do is to detect that the Rigol is connected. Also, it's going to send that command that we sent through Max, and the manufacturer and the model is going to appear here. All right, I'm going to click in this one, double click, and voila, here it is everything. Now I'm going to search. And with this driver, here it is the characteristic, the model which are supported, and all the family of the digital multimeter is supported, and also the port is very important, okay? So you have USB port, and it's also for Linux, Macs, and Windows, all of them. Perfect. So the thing that I'm going to do now is to install, okay? And we are going to install from a repository. And everything done. Start using the driver, and you have, okay, section 4 of this video. And before diving into LabVIEW, let me show you what is the experimental setup that I have built. First, the LM35, which should be supplied somehow. I didn't want it to use any kind of external supply, so I took advantage of the USB port that you have in the front panel, and from there I took 5 volt. That is going to supply enough current to make the sensor work without any problem. Then the pin that you have in the middle, there it's the voltage proportional to temperature. That is going to be connected to the positive of the voltmeter, and the negative, okay, to the negative terminal. And now the thing that I'm going to do is to show you that works. I'm going to hit it a little bit, okay, with my hands, and you can see that that is going to, it's working, okay? So now is the moment to go into LabVIEW and see, okay, what is the thing that we can do with that. Time to speak now about the application in LabVIEW. The whole project that I have built, the link to download it, it's available in the description of this video. This is the front panel, nothing special here, not rocket science. So here we have the temperature, the stop, and maybe the only thing that is remarkable is Visa resort name, that when you roll down, okay, you should have here Rigol multimeter as we had in Measurement and Automation Explorer. What do we have under the hood? So let's go to take a look here. So this is a while loop that is going to repeat over and over till you press stop or you have some kind of error to the error line. No worries. Let's go to this part that is the initialization. Here is our Visa resort name that goes to initialize, and also at the end we have close. Typical configuration when you have to establish some communication with external device. And also for this third party's instrument, I usually use initialize and close, but in the middle, okay, I'm going to use SCAPI command and Visa write and read. So this one that you have here, it comes with the palit or the library that we installed before. So by the way, you can find them in instrument IO, instrument driver, and here it is, Rigol, initialize and close. Okay, so after the initialization, the thing that I'm going to do is to select what repertoire of instruction or commands I'm going to use. Yeah, that is very cool. From this device, you have 3 sets of commands, basically Rigol, Agilent, nowadays Keysight, and then Fluke, so you can reuse your code. You can change this repertoire of commands here in LabVIEW. This is the syntaxes that you have to use. You can find that in the programmer manual, okay, but also you can do it from the front panel. I'm going to show you how. So first, look that here we have remote, okay, and we should have local. So local, we have to press here, and now it's changed to local, and utility, which is in this corner, and now it's CMD. And here it is, Rigol, Agilent, or Fluke. So far, it's going to be Rigol, and done. Okay, anyway, this code is going to do the same. And then once we are inside the while loop, the thing that I'm going to do is to send a command by this visa and SCAPI command. And the idea is to measure a DC voltage. So measure volt DC question tag. I think that it makes sense, this command. But the good thing is you can send this one on that one. So the Rigol set, okay, of command is very flexible, and this is something that I like because believe me, SCAPI command sometimes at the moment that you left behind some kind of space, capital letter, the instruments start to beep and you don't get anything. From here, after that, the thing I'm going to do is to read. I'm going to take the data in the string, and basically that is going to transform that into numeric and get the temperature. The only thing that left is this 2 seconds. I'm going to wait 2 seconds in order not to stress too much the device. Doesn't make sense to repeat the temperature so fast, okay? And I'm going to take the measurement each 2 seconds. So the thing that I'm going to do also is to activate the slow motion, the highlight. And let's go to see what we have. Okay, so look, this flash means that it's changed now to remote, everything okay, and here it is, okay, our temperature. Right, I'm going to change again, and the thing that I'm going to do now, as usual, is to hit the sensor, and yeah, it's increasing. Nice thing, okay, kudos to Rigol for keeping the display activated. Some other devices, once you establish the communication in remote mode, get blank or disappear. So still you have the display there. All right, mission accomplished, everything done. I hope that you find this video useful for your application, and also I hope to see you soon in my channel. Till the next time, bye bye.